Hi everyone, I'm Saksham and I'll present our work on audiovisual dataset distillation. I would like to thank my co-authors for all the help and contributions to this work. Over the years, we have observed an unprecedented increase of multimodal dataset sizes, which pose a challenge to researchers due to escalating computational and storage requirements. The task of dataset distillation is to learn a synthetic representative dataset which can replace real training data. Previous works have shown that each class can be represented by even a single data point in representative dataset. Replacing real training data with representative dataset can reduce storage, training time, hyperparameter search time, etc. A good representative dataset should have a comparable performance on unseen real test data. Specifically, first we create a representative synthetic dataset using dataset distillation techniques, followed by training on two separate networks from scratch on these two datasets independently. Finally, we inference our methods on held out real test data and expect a comparable loss and other metrics. Previous research on dataset distillation has primarily focused on image-only datasets, while multimodal datasets with additional modalities have recently seen a rapid increase in size. Hence, we propose audiovisual dataset distillation, a novel task aimed at creating distilled audiovisual representative dataset. This dataset should not only retain representativeness of individual modalities, but also the inherent natural alignment between audio and visual components. Note that each video is represented using its center frame and corresponding audio in our case. Our method is based on image dataset distillation using distribution matching. Distribution matching iteratively tries to reduce the mean of real and synthetic representative data distribution. Unlike usual machine learning frameworks, the image pixels are learnable parameters here, and loss is backpropagated to update these pixels. And to analyze audiovisual integration in this distilled space, we first introduce vanilla audiovisual dataset distillation method, which individually matches audio and visual distribution. And here we extend the image only mean matching loss to include audio mean matching also. Audiovisual integration has shown to outperform unimodal approaches, and we find similar trends for our distilled data. Here we show the classification accuracy over test data by models trained on vanilla distilled audiovisual data. In general, we find fusion methods to outperform unimodal performance. Vanilla approach does allow us to create good individual representations, but still have the alignment missing. Distribution matching limits simple cross-modal alignment losses due to the use of randomly initialized embedding extractors. As shown here, direct cross-modal mean matching losses result in unstable and unaligned synthetic data. To overcome this challenge of randomly initialized embedding extractors, we introduced two novel cross-modal matching losses. First loss implicitly distills cross-modal alignment. Specifically, we match the sum of real audiovisual mean distribution and sum of synthetic audiovisual mean distribution, which can be formulated as matching cross-modal mean matching. Next, we introduce loss to maintain the real cross-modal gap between real and synthetic data. Additionally, we use to initialize synthetic data using herding method and factor technique to increase the number of features. Our results on 4 datasets and comparison with baseline show outperformance on audiovisual event recognition as well as class-wise cross-modal retrieval. Uh, Qualitative comparisons show that our digital data can better represent the underlying audiovisual distribution. And to conclude, we introduce a new problem and show that audiovisual integration does help in distilled scenarios, though we need carefully designed cross-modal alignment losses. Comprehensive empirical and qualitative comparison highlight the benefit of our approach. In the future, we would like to explore extension of a method to longer durations of videos, reducing the gap with entire data, and instance-wise distillation. Thank you.